Assalamu alaikum, starting with the name of Allah, the most gracious, most merciful. This is the story of decades, and I am Eram Tariq. Let's begin the story as we don't have time. So I am going to share my slides with you, which are really impactful. So today we are discussing the institutional we are studying the institutional decarbonization 1.5 Celsius. Yes, 1.5 Celsius extreme climate events La Nina, right? Which is expected to come. So let's begin. As I have told you that it's the story of decades, and the decades between 2011 and 2020 was one of the immense transformation marked by aspiration, challenges, and lessons that shaped not only a business, but a personal journey of resilience and growth. In 2011, a vision was born, a dream of contributing to a greener world by harnessing the power of renewable energy. And we did a lot before 2011. The renewable energy was the energy empowering end use only. In initial years, what you can say the worldwide of activity, from navigating technical challenges to fostering partnerships and securing investment, every milestone achieved felt like a step closer to our mission. However, journey was not any journey is not without the struggles. So in 2017, due to some health issues, the company was paused. So, but it's opened doors to new perceptives, you can say, the passion for sustainability and creating positive change. So with this, right now, we are here to discuss the decarbonization, because by the end of 2020, the decade had been full circle. It was no longer just a story, it's the new vision. So why decarbonization, right? But the question is, what is decarbonization and what is 1.5 degrees Celsius temperature limit? First, we will understand that 1.5 revolving around the sun and Earth is revolving the Earth around the sun completed. So this leading to vibrations in variation in temperatures, precipitation, and climate change occur in different regions. So due to this, we have winter forecast for global temperature from 2024 to 2025. This indicates cooler and wetter conditions in the region, such as northern United States and in southern Canada, while areas like in you can say in southern United States, they could experience the drier weather, as the prediction is there for this, that the weather will be warmer in the southern part of the America. So the global system has many large scale and small scale reasons for that. The temperature fluctuations are linked with poles, equators. As we head into autumn, the polar region starts to cool. Less energy reaches to North Pole as the sun gets lower. But as the polar temperature drops, the atmosphere further to the south is still warmer as it continues to reach light and energy from the sun. So one of the reasons behind this fluctuation of temperature is the collapsing of the polar vortex. This is the, you can say the warmer regions, the cooler regions. So one of the reason is the drop of the, rather the collapsing polar vortex. So what is the polar vortex? The question is that, what is that polar vortex? We have to understand these terms and we have to understand this little science because we are in the state of emergency. We don't know what's going to be happen in next coming days. So for knowing all this climate change, we have to, we must have to learn and we must have to know little science as well. So what is the polar vortex? Actually, polar vortex is a large, low pressure system of cold, dense air swirling near the Earth poles. Right? This right. This is the dense air swirling near the Earth poles, strongest in winter, occasionally it weak or shift, sending fresh Arctic air into lower altitudes, causing extreme cold spells. Right? So the Pacific Ocean is the largest and deepest ocean on the earth. We have to know something about Pacific Ocean too. The Pacific Ocean is the largest and deepest ocean on the earth, spans over 63 million square miles and touches 5 continents. You can see here the Pacific Ocean is the largest ocean. So it plays a crucial role in global weather patterns, marine biodiversity, and trade routes. Okay. So the Earth rotational speed is faster at the equator. Here, this is the equator. So the at equator, the Earth moves with faster 70 kilometers per hour due to the greater circumference. Or at the poles, the rotational speed is effectively zero, right? At the poles, when we move towards the pole, the rotational speed is zero. The rotational speed is zero, right? So winds moving from equator towards the North Pole are influenced by these are the winds. This arrow shows the winds. This arrow shows the winds. These are the winds that flow towards the North Pole are influenced by greater force, causing more to deflect eastward and forming the winds, trade winds, and westliners. The movement drives global weather system and redistributes heat across the planet. This effect is called the Coriolis effect, right? So here the winds, they move clockwise. See? So the Coriolis effect causes winds to reflect to the right of their path of motion. This results in clockwise circulation around high pressure system and counterclockwise circulation around low. This is the clockwise. This is the clockwise, right? Clockwise. This is the clockwise, and this is anti-clockwise. Okay, fine. Now we will move ahead. So due to the Earth circulation, right, as I already mentioned you, because the Earth rotates on its axis, circulating air is deflected towards the right in the northern hemisphere, and in the it deflected towards the southern hemisphere towards the left, right? So wind patterns are influenced by Earth rotation. The Coriolis affects the temperature difference, leading the consistent global uh, wind belt like the trade winds. So western lies and polar eastern lies, these patterns drive ocean currents, weather system, and climate across the globe. You can see here is our region, here is Pakistan, and here is India. So we have to discuss the upcoming climate patterns in South Asia, that is in Pakistan and in India. What happens? So these winds coming from Pacific Ocean, these winds, they are coming from the Pacific Ocean. Actually, these winds, you can say the set the trends of climate or climate patterns in the South Asia, in India and Pakistan. So these winds coming from Pacific Oceans are termed as trade winds, right? These winds are trade winds, and these winds create these trade winds. These are very strong winds, and these winds creates an effect on climate of which is termed as ENSO. So before discussing ENSO, just look at climate patterns in the year 2024 in Pakistan. We faced extreme heat wave, uh, floods, and we also experienced hailstorms in different areas of Pakistan. Or considering the national weather extremes in January 2024, you can see in January 2024, we have hottest day in Turbat, right? In Balochistan, we have coldest day 1.5 in Malam Jaba. We have minus 10.7 Celsius at Zakardu, and the warmest night in Gwadar. This all weather patterns. This is the weather pattern of January of Pakistan. एक जो हमारा यानी कि जिस हम मुल्क में रह रहे हैं उसके एक महीने में एक दिन में टेम्परेचर जो था वो क्या था तुर्बत में 32.5 सेल्सियस एंड इन at Malam Jaba it is 1.5, in Skardu it is minus 10.7, at Gwadar it is 18.5. So it is so very much alarming. So we have faced temperature anomalies, right, during the year 2024. Now come towards the ENSO, right? So what is the ENSO? ENSO is a Niño southern oscillation. So it is recurring climate patterns involving change in the temperature of waters in the central and western tropical Pacific Ocean, right? So this is the situation. So what is the natural phase of ENSO? There is a term, the natural phase of ENSO. So the natural phase of ENSO is the condition dominates in the Pacific Ocean. So during this phase, sea surface temperature and atmospheric temperature patterns are close to average, leading to more typical stable weather patterns. So when this is the phase one, natural phase, and so this is the condition which is called ENSO, as I told you. So this refers to the wind patterns. This depends on these conditions are depends on this condition depends on wind patterns. So this is the natural phase, and when the both this is phase two, and El Nino is the phase two, and La Nino is the phase three. So these are actually the wind patterns, and they are stable. When they are stable, when the you can say the atmospheric pressure and temperature are uh, stable, they are normal. When there is a fluctuation in temperature, then we face the extreme weathers, and the situation is termed as the term this situation. We say this is the La Nino or the El Nino situation. So what is this situation for further, for telling you for further, I will explain further. So this is the, for clearing the concept of this El Nino and La Nino and so everyone knows that water is cool. Everyone knows that water is cool and the land is warm. So water is cool and the land is warm. So the land surface is heated more. When there is sun, then definitely the land surface heated more, creating an area of low pressure. Now understand this phenomenon, right? When the what happened when the land surface heated more, creating an area of low pressure, the cooler air over the water at the higher pressure moves towards the warmer land, right? So what happened next? At night, the reverse take place. The winds from the land moves towards the sea. And when this happens, what is the result? Result is the increase in the temperature, right? We are understanding 1.5 Celsius. This is the normal phenomena. It's happened on the earth, right? But what is abnormal? What is abnormality? Abnormality comes. This is the temperature of coastal area. This in this way, the winds due to the flow of the winds, the temperature at the coastal areas are depend on the this circles. But what happens when we due to the greenhouse gas emissions, when the temperature of the land rises due to greenhouse gas emissions and this what is called global warming, then what happened? The shift of the temperature, the rising temperature shifted towards the sea with the help of what? With the help of winds. This is the circle, right? This is the circle. This is the area of high pressure, area of low pressure, and the sun and all these factors. These are the you can say the air pollution. This contribute, and there is that at coastal areas the trade winds are created by the cycle of warm moist air rising near the equator, and the air definitely eventually cools and sinks to the this is the cycle. This is called the Henley cycle as well, Henderson as well. So no need to explain it anymore. This is just to clear your concept that what is the global warming and why the greenhouse gases are emissions are why temperature is rising. So that's why the 1.5 temperature limit is a target set by the Paris Agreement to prevent dangerous climate change impact, aiming to reduce the risk of extreme weather, rising sea levels, ecosystem disturbance, right? So now we, as this is the, you can see the more clear impact of the blowing winds or at our globe, that how these winds carry. These are the cooler in wind waves. These are the neutral wind waves, and these are the hottest wind circulating all the time at the globe, right? So now we will understand the institutional decarbonization. Among these greenhouse gases, the carbon dioxide is the most, you can say, the dangerous or the most hazardous gas, due to which the global warming right now methane is also have the more impact than carbon dioxide, but totally or collectively rather, the terms which we used for the limiting this carbon emission is decarbonization. So decarbonization refers to the process of reducing carbon dioxide emission by uh, uh, transitioning to cleaner energy sources, by improving energy efficiency, and by the crucial strategy in mitigating climate change and achieving global sustainability goals. We have to decarbonize over institution, either not only the manufacturing units, not only the industry, but school, colleges, markets. All of us have to make over decarbonization policies. So this is called the institutional decarbonization, and this decarbonization involves implementing strategies within organizations, institutions, or government to reduce carbon emissions, often through energy efficiency improvement, renewable energy adaptation, or sustainable practices. This approach supports national and global climate goals while promoting environmental responsibility and operational cost saving as well, right? So setting up baseline scenarios for decarbonization involves assessing current emissions and energy used to understand the starting point of reduction efforts. And why we do so? Because there is extreme due to the rising temperature. As you know, we have faced the abnormal patterns of winds, right? We are facing some hazardous situations, and we are we are right now in entering in the stage of La Nina, right? This is in abnormal phase. This is due to the rise of the temperature. As I discuss all these things, that why blowing winds are so very much important. And from Pacific Oceans, the winds blow towards over, over subcontinental regions on, you can say, Arabian Sea, right? This is the situations. And when the and when we, and if we fail to limit over temperature, we will face extreme climate situation. Right now, I can't explain it, but it is the prediction that in coming days, the climate will show its, its muscles, right? So it is a strong prediction that due to this upcoming La Nina effect, we will face extreme weather. What these extreme weather will be, we don't predict, but definitely we are entering in that era in which we will experience extreme heats, extreme wildfires, extreme flooding, and we here in this region, we are at the risk of extreme flooding, right? So I don't know what happened, but it is going to be happen. So so it is very much important for us that we will start making over decarbonization policies, institutional decarbonization policies, as we are at the extreme. Last year we experienced extreme heats, right? So this is the, you have, all of you have listened the term early warning. So this is the early warning system. If we study the patterns of weather in 2024, this is early warning for us that we have to take action. We have to take serious action. We have to make serious policy to limit this 1.5 degrees Celsius, our temperature up to 1.5 degrees Celsius, what efforts we can put in. And we are guided by Allah subhanahu wa ta'ala as well, that Allah is who strengthens the wind. So that they raise clouds and then strengthen it along the heavens as he will speaking to the breaking it into fragments, and thou beholds the rain come forth and from the intestines. Therefore, then when he makes it fall upon such of him abundant as he will flow, they rejoice. So we are not strictly, but strictly guided by Allah subhanahu wa ta'ala as well. That these winds, these wind patterns, these changing temperature, all these things are so very much important. So we have to not just by you can say we don't have to go for the greenwashing. We have to uh, we have to study the reasons and the science behind this changing climate and this rising temperature. So these this is the you can say the whole story till now. And thank you all of you for listening me, and definitely all together we will make some good policy to address this upcoming climate change. Thank you.